Very good. Thank you very much. It's a pleasure to be here. Thank you very much, Alexander, for very rich presentation, and this will help a lot to my presentation. In fact, I am Hamid Sattari, co-founder and CEO of CCRAFT, a new foundry that manufactures thin film lithium niobate chips. Briefly about CCRAFT, we are a spin-out from Swiss Center for Electronics and Microtechnology. After 6 years of development in our in-house fab, we decided to spin out to industrialize this technology. And the key factor here to notice is that we operate from our in-house facility. This is quite important because we have full control over our recipes, and this is quite important for the IP, and also it brings flexibility in our recipes. We have been working with customers since 4 years in CSCM. We were offering the platform through pre-commercial offering, and this helped us a lot to know a customer's pain and to know that how we can add value to their products. So it is clear that one material cannot handle all the operation needed for photonics, but basically TFLN is chosen for ultra-fast modulation and maybe frequency conversion. And today focus is basically in datacom and telecommunication market. That's why high bandwidth operation of lithium niobate is really in focus. But there is no commercial foundry offering TFLN in volume and reliability required for industry. Briefly, if you just compare lithium niobate with mainstream PIC materials, you see that for modulation, TFLN seems to be the option to choose. And at CCRAFT, we focus on further maturizing the technology and bringing access to broader ecosystem to adopt this technology. So if you look at the value chain for photonic integrated circuits, in fact, reliable manufacturing at high volume is the missing block that brings the bigger value to the chain. It's not like semiconductors that fabless companies and design houses, they bring the biggest value. TFLN stands in unique position because that's already recognized by industry, thanks to experience of industry working with bulk lithium niobate. And in fact, with the TFLN players, we believe that this is the best material for photonics because its options goes beyond datacom and telecommunication. That is enabler for quantum, optical computation, advanced sensing, and so on. Yet the missing block is industrial grade manufacturing, and with CCRAFT, we are closing this gap. When we are talking about thin film lithium niobate, Alex nicely covered that is quite unique material, hard to etch and pattern, and you need dedicated facility for that. This is one of the barriers that taking lithium niobate to a standard CMOS foundry. We did this. From day one, we have been working in an industrial environment. You don't need big fab because the market demand, you see that still TFLN is niche inside a niche market. And from day one, we developed a technology that today is the most advanced in the world. I'm talking about number of technology steps. We don't only etch one waveguide. We etch lithium niobate in different levels. We have several metallization layers. We protect this with clad, and nicely we open this cladding in different levels for integration and advanced circuitry and so on, all in industrial environment. And it's not only fabrication, that is also protected by de-risk PDK. So not only simulation, but also manufacturing and testing in more than 10 cycles has happened. So we provide customers also with the measurement data supporting all individual building blocks. So in terms of solution, so we provide different solutions based on our foundry processes. First, monolithic lithium niobate. We are running MPW 2 days. You can also jumping into dedicated custom runs for you and qualification for high volume runs, all empowered by tested PDK. But look, silicon photonics needs to get enhanced immediately. One option would be microtransfer printing. So you need a supplier for thin film lithium niobate chiplets to take those chiplets and put on your silicon photonics. We have developed a nice recipe with high yield. We deliver wafers with 10,000s of chiplets ready for your silicon platform. Today, ready. We are ready to engage with people. On top of that, we are really substrate agnostic. If you somehow bond your lithium niobate dyes or wafers on your silicon photonics, we are here to just continue from there. So process lithium niobate, back-end of line processing, metallization, and so on. We tested few of our recipes for TFLN on TFLT, and the result turned out to be amazing. So we see some traction on TFLT, and we do internal development to also offer TFLT in near future. And also from customer interaction, we see that they like to have monitoring photodiodes in the platform. This is something that in research level, we have practiced several times. Amazing result we obtained, and we are thinking to obtain it. We are thinking to integrate photodiodes also in our platform in upcoming years. I'm talking about the short future. Today, we offer MPWs, dedicated runs, few wafers that they serve the best for niche markets in quantum and sensing, but also for qualification runs. We already unlocked the capacity required for high volume production from our certified foundry at CSCM in Neuchâtel, and in different phases, we are expanding our fab in the region. We have secured the clean room area. Now we are populating it with industrial tools to deliver 20,000 of wafers per year in next 3 to 4 years. So with this slide, I was thinking about, what are the options for TFLN technology from monolithic to heterogeneous? What's their status, pros and cons? Please note that this is just personal perspective from Mohammed Sattari. There are several points that you might agree or disagree. That is food for thought and discussion. Option 1, monolithic TFLN, status clear, very strong momentum because of clear reasons and AI revolution. Pros, there has been several years of research behind thin film lithium niobate. Several papers that Alex showed, nice bandwidths, low insertion loss, and so on, and compatibility with value chain. If you complete this foundry part of value chain, whatever that works for silicon photonics, it will also work for TFLN in terms of integration. Cons, lack of reliable manufacturing at volume. And there is a big question. What's the meaning of volume here? It needs a bit further thinking. We enter to heterogeneous or hybrid domain. So whatever word that you pick doesn't really matter. So option 1 is TFLN on silicon photonics using microtransfer printing. From my perspective, it sounds interesting, but it seems that industry still lacks a bit confidence to adopt it. Pros is that you are really flexible in terms of where to place these components, and it might also bring some cost advantages. In terms of cons, so there is lack of supplier in lithium niobate side. We hope that with CCRAFT we close that gap. Footprint limits, device size of lithium niobate is one of the, I would say, issues that Alex already mentioned. And generally lack of experience in terms of transferring these chiplets, and also PDK. Who will be the PDK owner? Who will develop it? So that there is still uncertainties around this technology. TFLN on silicon photonic bonded, either die to wafer bonding or wafer to wafer bonding. To me, it seems that is the only viable solution for silicon photonic that could really save silicon photonic to continue its life by enhancing modulation. Compatibility with the standard tools and methods is there. Again, lack of foundries. So weak supply chain and wafer size mismatch here is important. So silicon photonic already moving to 300 millimeter, lithium niobate industrial supply for wafers that is still in 6-inch. And if you add lithium niobate on top of silicon photonics and other processing, so yield will drop. So it will take years to get to the yield that you get with monolithics, and lead time issue. So you add process and other steps to your full process, so chips will be delivered later than monolithic case. Final option, last option, TFLN as modulator. You bring photodiodes and lasers to TFLN. This is really the dream of TFLN, guys. Big thing, lithium niobate as the main platform for photonic integrated circuit. Today, that is in very low TRL. And personally, I don't see any solution provided by this approach in the next 5 years. Of course, the biggest advantage is that all-in-one best platform for many applications, not only for data and telecom, very wide range of application you can provide, but you can provide with this approach. Cons. What I see that is missing now is a vision. Why we do this? While maybe other approaches with heterogeneous integration could get better results faster, more yields, and lower cost. So no supply chain today. Final presentation, final slide. So what CCRAFT can do for you? The most important thing is that today we have chips for you. You can order chips from us. You can loan chips from us to test start your product development, monolithic, heterogeneous, and foundry services. We are also very interested in co-development and joining the force to have partnership to strengthen the supply chain. What we need from people, of course, we work closely with PDK enhancement and enablement partners, OSAT partners. We want to work closely with them to move our measurement standards towards industrial grade. Quality assurance is quite important. And telecom, datacom demonstration with big players, that is, of course, something that we can join force, small companies together to convince those big players that this is our technology, and we have clear path to scale this up. With this, I would thank you, and I am open for questions.